Welcome to part 8 of our live training process here with our drag race Honda S2000. This tutorial we're going to be focusing on a couple different topics, taking a look at setting up our gear detection for the sequential transmission, acceleration enrichment, fueling, making sure that's in line, and lastly working with our blow-off valve base boost control so we can use that as power management in our lower gears to be able to bleed off the flow and the pressure to the engine. The boost control alone is going to be reactive fast enough for a drag vehicle, so this is going to be the next step, and making sure that we have the turbo always spooled up and on point, and that we're going to be managing that power again with that blow-off valve. So a lot to cover here in the tutorial. Let's jump in so we can check this out. Welcome back to our live training session here with our drag race Honda S2000. Now this tutorial we're going to be focusing on setting up a few different things such as our gear detection, our transient fueling, which is also known as acceleration enrichment fueling, as well as our blow-off valve based boost control. So we're going to be looking at the blow-off valve boost control, the very last portion of the tutorial. We still have the vehicle here on the mainline chassis dyno, so we'll see the power differences when we start to enable that and use the blow-off valve to act as a boost bleed or a boost leak, essentially a controlled boost leak, and see what kind of power we can chop down. So when we launch the car, we're going to be able to manage the boost a little bit better for this drag race application. And I'll explain a little bit more in depth when we get to that point. The beginning of the tutorial here, I want to go focus on setting up our gear detection. We want to have gear as a way we can log the specific position that we're in, the transmission that we're using. There is no gear position sensor on this transmission. This is a sequential transmission. It's a 5-speed sequential transmission. It's an H pattern format. So what I want to do is jump in and set up our gear detection so the link knows what gear we're going to be in. Now the way we're going to do this is going to be a ratio of RPM and speed. So it's going to be a calculation and we have to enter that into a table manually in order to figure it out. Really straightforward to do that. So let's go and take a look at how to do that right now in the beginning of the tutorial, and we'll keep moving on to the other topics. So I am connected right now to my vehicle. We can see right now the file that I'm saving here and working with is blow-off valve boost control. That's what I'm going to be calling this specific tutorial. I'm going to move from my fuel tab over here into my VSS gear tab. In here, we can take a look. We have our setup. We configured all this when we were setting up our base map. Let's just go over this real quickly. We have our driving wheel speed source as our max rear speed. So this is rear wheel drive, and we have individual ABS sensors coming into our link, broadcasted on the CAN network using the ABS factory OEM Honda CAN module, or the ABS module, broadcasted on our CAN network. So we're bringing all those wheel speed sensors in and we're pointing it to the fastest rear wheel speed. And we're doing that specifically so that if we're referencing our driving wheel speed, we're always looking at the fastest wheel that's driven. Now this doesn't have a spool in it, has a torsion-based diff, so there might be different wheel speeds at our rear wheels, and we always want to look at the fastest. The reason why I set this up here is because we're going to be using it for a slip calculation for traction control purposes. So we always want to take kind of the worst case scenario, whatever wheel is going to be spinning more than the other is the driving wheel speed calculation, or the speed source. So I have it here on max speeds. The driven wheel speed source we've set up to the average front speeds. The driven speeds are going to be essentially our ground speed. That's our front wheels. They're going to be pretty much the same going on drag strips, so I have the average of them. It's going to be taking both into account. Acceleration source is our driving wheel speed, because that's going to be, in this case, rear wheel drive. That's our rear wheels, so we have it set as such. Now we do have here on the right front, left rear, and left front, we have different CAN frequency inputs. These are all what's coming in on the CAN network from the OEM ABS module. We broadcast it over CAN, and we've assigned each individual wheel speeds. Now, I'm not going to be able to drive this off the chassis down in here for the tutorial, but in the pits, we'll have to just do some driving through the pits and making sure all the wheel speed sensors are registering and reading the same to each other. They should be. That's why we have our calibration here at 0, because the kilometer per hour or mile per hour as we're broadcasting those speeds into our link, those are going to be calibrated already from the Honda ABS module and pushed in here to the link on the CAN network, so we shouldn't have to do any calibration. They should be already calibrated right from Honda. We're simply broadcasting what those speeds are coming out of that ABS controller. Again, that's why we have the calibration here at 0. Normally, if you have a wheel speed coming in and it's a wired into your link, you would have to go in here and set a calibration number of value so that it knows the pulses per rotation that's going to be associated to getting a speed reading out of the wheel speed sensor. So we can see what that's going to be defined as there. Gear detection, this is where we want to focus our efforts. So the gear detection and gear ratio table. The gear detection mode, we have it set on RPM speed. We do have some other options here off CAN. That would be a CAN-based gear speed. analog position sensor. That would be if we had an actual position sensor on our transmission. It might have been an option on this transmission, I'm not sure. This is a sequential 5-speed transmission, but there is no gear speed sensor or position sensor. So we're going to set this up using our RPM speed, which is commonly how I do everything in terms of gear detection. So the number of gears here is a 5. We have 5 speeds on this sequential transmission. Gear detection type, there's some options here. ECU calculator or user define. I like to go and set up user define. That way I can go and set up my gear ratio table here specific to the vehicle I'm working with. Now if we do use the ECU calculated, it's going to try to go and calculate the table and populate its own numbers in there. I'm going to go ahead and just set up user define. That leads me into my gear ratio table. We have our gears 1st through 5th here, and then the actual values in here. That's the ratio of RPM and speed. We can keep track of what that's going to be here in our parameters list. If we're data logging, we can take a look here at our gear ratio. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.